Unit 4.3, Congruent Triangles. We'll start out with the definition of congruent polygons. If we know that two polygons are congruent, we know their corresponding parts are congruent. If we look at two polygons and their corresponding parts are congruent, then we know that the two polygons are congruent. When we're looking at polygons to make sure they're congruent, after we have shown that the corresponding angles are congruent, we need to make sure that the sides between the corresponding angles are congruent. For example, in this picture, we know that angle A is congruent to angle H. And if we look at angle B being congruent to angle J, we need to make sure that the side between those two are also congruent. Once we know that we have two polygons are congruent, we need to make sure that when we have the congruent statement, that the lettering is in the correct order. Because now we know that angle A is congruent to angle H, angle B is congruent to angle J, we know that side AB is congruent to side HJ, and so forth. One of the sayings, or one of the things that we shortcut, is saying CPCTC, corresponding parts of congruent triangles are congruent. Looking at the first example, we know that angle A is congruent to angle R. We're told that. We're told that angle B is congruent to angle T. We're told that angle C is congruent to angle P. We are told that angle D is congruent to angle S, and angle E is congruent to angle Q. So we have all the corresponding angles are congruent. If we go through the list of corresponding sides, we'll find that the corresponding sides are congruent. So to write the congruent statement, I follow this list of angles. I can say that A, B, C, D, E is congruent to R, T, P, S, Q, and that's my congruent statement. Here we're given the triangle TIP is congruent to triangle GNO, and we want to find the values of X and Y. First of all, locating X right here, I have X minus 2Y, so that's two variables in one. I have to start with Y right here, and that corresponds to angle O. I know that angle O is congruent to angle P. So since angle P is congruent to angle O, or the measure of angle P is congruent to the measure of angle O, I have that 40 equals 6y minus 14. Add the 14 to both sides, and I have that 54 equals 6y. Divide both sides by 6. And I have that y is equal to 9. Looking at this side here, GN is congruent to TI, which is right here. So I have that x minus 2y equals 7.5. Plugging in the y that I have x minus 2 times 9 equals 7.5. So x minus 18 equals 7.5. So x equals 25.5. The next item is third angle theorem. It tells us that if two angles of one triangle are congruent, then the third angle must be congruent. So it gives us a little shortcut. Without proving everything, we can prove it to ourselves by subtracting each of those from 180 to find out what angle A and angle L are. We're not doing two-column proofs in this, but I do want to look at problems like this, and we're going to make a list. If at sometimes we need to give a reason why certain things are done, I want you to do that. So I'm looking at listing the three sides that are congruent and the three angles. I know that side LM is congruent to PO, and that was given to us. I know that LN is congruent to PN, and that was given. And lastly, I know that MN is congruent to OP. So I have all three sides congruent, and that was given to us. Looking at the angles, I have that angle L is congruent to angle P, and that was given. I also know by vertical angles that these two angles are congruent. Now to list it, I'm going to have to use all three letters. So L, N, M, this is M, right? So angle LNM is congruent to angle PNO. So there's our center letter, which is N. So we have two angles congruent and the two triangles. So the third angle has to be congruent. So we know that angle M is congruent to angle O, and that's the third angle. Writing our congruent statement, we have angle LMN is congruent to triangle PON. That's because we showed all the corresponding parts were congruent. In algebra, you learned about the reflexive property that something is congruent to itself or something is equal to itself. Symmetric works too. It doesn't matter what order you put the two items around the congruent sign. And then we have the transitive property. If triangle ABC is congruent to triangle EFG and EFG itself is congruent to JKL, then these two triangles must be congruent. One of the tricks in solving triangles, especially when they have a picture where the two triangles are overlapping, is to separate the triangles. Draw them separately. It helps you see what you're looking at. So in this picture here, I'll separate out the triangles. This will be A, B, D, and I know that this one was 30 degrees. The other one, here's C up here, and A and D. They tell us that the two triangles are congruent and that the measure of BDA is 30 degrees. We want to find the measure of CAD and CDA for both of those angles. So for the first one, I want to find the measure of CAD. So CAD is right here. Well, looking back at that, I know that angle A in my second triangle is congruent to angle D right here. So that means that the measure of angle CAD is 30 degrees. Finding the third angle here, I have a 90-degree angle already. So to find the third one right here, I would do 90 minus 30. And that would give me 60 degrees. So these two remaining triangle angles right here in the triangles are 60 degrees. So I wanted to find the measure of angle CDA. So CDA is 60 degrees. That concludes our lesson for 4-3.